So the four types are epithelial, connective, muscle, and nerve. And if you look on the first page of chapter 5, there is a table that will tell you what each one does, where it is located, and so forth. If you remember, we said the basic unit of organization is the cell, right? Tissues are one step above that. We're talking very, very generalized here. And I mean very generalized. Each of those has a pretty obvious function that the name tells you. Epithelial tissue covers things. It covers the outside of the body. It covers the lining of the cavities in the body. It covers the lining of the hollow organs. You get an idea here. What do you think its main function is?
Protection.
Protection. Yeah. Pretty straightforward, pretty simple. Now it does do other things. A lot of them are involved in secretion, so forth. But the simple, blunt fact of the matter is just a covering that protects. If you ever read an old-fashioned hardback book, it's got a harder cover than the pages within. Even a paperback, the covers are typically a stiffer cardboard, aren't they? Protection. And it does a very, very good job of this. What does it protect from? Anybody want to take a guess? Sierra, name one thing. You don't know what your skin protects from.
Injuries or bacteria?
Injury, okay. Abrasion, cut, would y'all agree? Physical, provides a physical barrier. Good job. What's another one?
Bacteria or dust entering the body.
Outstanding. Infection, it keeps other organisms out. What's another one? Somebody comfortable with the temperature in here? I notice most of you are wearing long sleeves. Some of you have a nice sweater on or a hoodie. Some of y'all are still freezing. Chloe looks like she's, keeps you warm, doesn't it? Keeps you cool, doesn't it? You get the idea? Protection. Connective tissue. Haley, what do you think that does based on the name? Connects. Good job. It literally holds things together or connects systems. Connective tissue is probably the most diverse of the tissue types. A lot of things that y'all were naming as separate tissues are actually going to be connective. Now it's easy to see things like tendons and ligaments, isn't it? Ligaments anchor the muscles, or tendons anchor the muscles to the bone. Ligaments connect the bones. They're what hold the skeleton together. But you might be surprised to know that bones themselves are considered connective tissue. They support, they articulate, they provide force. Blood. Most of you be surprised to know that blood is a tissue. But it is a tissue, it is connected. Where do you find blood in the body, Aiden? Just about anywhere, exactly. Good job. Because it circulates through the body, it connects this various organ systems together. Does everybody see how this works? What was another muscle, right? Muscle tissue does one thing and one thing only, and that is it provides force. It provides force. Now, how you use that force can vary quite a bit, right? Movement, processing food, but it's the muscle that provides the force. Don't fall asleep on me. Don't fall asleep on me. Give me 15 minutes in before you start. My ego can't handle this. I put so much sleep in 15 minutes. What's the last? Nerves. Nerves primarily do one thing, and that is they carry information. Carry information. Carry it from here to there and everywhere in between. If you wanted to add that they process information, I would go with that. Because the brain, in addition to transmitting, also processes. But as a simple 1 or 2 word definition, transmits information. Muscles provide force. Epithelium provides what? Protection. And what does connective tissue do?
Holds together.
Holds together, connects. See what a simple quiz that was?
Yeah.
Don't worry, I'm not gonna grade it for content, I'll grade it as a participation quiz if you were here. But I wanna keep you on your toes and remind you, this is an ongoing process. I know we had the test last week, but I still expect you to show up ready to go for the next one, okay? Be glad you got me in my old age when I'm nice and easy going. I used to be a terror. Always laughing at me. You're right, I never was a terror. So does everybody feel comfortable with the tissues here? Now, within each tissue type, you're going to have specialized subtypes. You're gonna have specialized cells within those subtypes. Each of those could have a very variable function. Just as an example, muscle. There are 3 types of muscles, aren't there? We've seen them in lab. Somebody name one. Smooth muscle, good job. Smooth muscle is autonomic, it's the automatic. The body doesn't have to do anything. It does not come under conscious control. It's also fairly weak. You're generally not going to have muscle spasms or anything in your intestinal or stomach, are you? Now you might, if you've ever had a bad case of food poisoning, we've all vomited at some point, haven't we? Get that non-hitting. But that's because you're trying to expel something. Normal process, we don't even feel the food moving through our digestive system until it gets to the end and we're ready to eliminate. What's another type of muscle? Skeletal, sometimes called striated muscle, sometimes called voluntary muscle. I'm gonna let you teach. Skeletal muscle is voluntary, which means we control it. It provides movement. Not by its own. The only thing it provides on its own is force. But when you combine it with certain connective tissues, like the bones and the ligaments and the tendons, it allows us to move, doesn't it? Yes,
You
ma'am.
said within each tissue type, there's subtypes, and then what else?
Specialized cell types. I'm going too fast.
Sorry to go that far back.
That's okay. You know me, I do. The more you talk, the less I do. That's better for everybody. So, what, we said skeletal, right? Sometimes called striated muscle. Striations are stripes or bands. I think when you looked at the different types last week, it was kind of obvious what the smooth muscle was hard to see, wasn't it? That's because there's not a lot to it. There's not a lot of it there. It's very weak, like I said. But the skeletal muscle striated muscle. That is what we use pretty much for everything. We can pack that on, right? I'm not gonna flex these guns, because I don't know if you can handle that. Yeah, that definitely. But joking aside, we can pump iron, put it on, we eat protein. What we're doing is we are adding muscle mass. The more mass we have, that means the more cells we have, the more cells we have, the more force we generate. If you look at weightlifting records that people have set, you look at the Olympic powerlifters, it's amazing how much physical force the skeletal muscle carries. What's the last type?
Cardiac.
Cardiac, the heart. Cardiac muscle is interesting because it resembles skeletal muscle. It's got striations, doesn't it? That's because it uses the same heavy proteins to conduct that movement. But unlike skeletal muscle, cardiac muscle is autonomic. In that way, it's like smooth muscle, isn't it? It's under the automatic control. You can't make your heart willingly stop beating, right? You can't willingly speed it up. You can't willingly slow it down. It's going to beat 24/7, 365 for however many years you live. Pretty amazing when you get into it. So everybody familiar with cardiac? Everybody comfortable with cardiac? What's another one? Nerves. Nerves are basically two types of cells, two types of subtissue. The first are neurons, N-E-U-R-O-N-S. Neurons carry information. That's all they do. If I put my finger on a hot stove, I'm going to receive two types of input, right? Number one, that it's hot. Number two, that it's damaged, aka pain. That information is going to travel through neurons, but through my brain. My brain is then going to process that information. Now that is still just moving the information through a network of neurons. The key there is the word network. We call it processing, we call it thought, but really, truly, all it is moving nerve impulses through a network. After I process that, am I going to take an action based on that? I'm going to send an action potential down to my muscle that says, pull that finger away. Neurons are easy to understand, right? Did you realize they're not the only type of tissue in nervous tissue? There's something called glial cells, glial, G-L-I-A-L. Glial cells are much smaller than neurons. And they're much more specialized. They support the neurons. They are what actually allow the nerves to function. Neurons essentially could not survive without the glial cells. They play a role in development and support. Well, we know we find neurons where? Lydia, where do we find neurons?
Nerves.
In nerves, exactly. Nerves are just clusters of neurons. You'll find them throughout the body. Generally, we divide this into two systems. The central nervous system, which is the brain and the spinal cord,
and the peripheral
What was
nervous
the first one?
system. Peripheral. Peripheral is just that, the periphery, the edge. It's anything outside of the central nervous system. It's really somewhat of an arbitrary distinction, but if you wanted to divide it into functions, you could say that the central nervous system is primarily a processor. The peripheral nervous system is primarily a transmitter and a receiver. A transmitter and a receiver. This includes things like eyesight, smell, taste. In other words, sensory input. You get an idea? That's part of the peripheral. And that's why I say transmitter and receiver, because it has to receive input. If I asked you where it's found, though, you could say anywhere in the body, couldn't you? It's a bit of a trick question. If I ask that question and I'm no more specific than that, and you just say anywhere in the body, are you going to get credit? Absolutely, because you answered the question I asked. Where do we find cardiac muscle, Chloe? In the heart, agreed. And only in the heart. Alyssa, where do we find smooth muscle?
Smooth muscle, let's say inner lining of the organs. Oh, are you talking about, listen, sorry.
I was talking to that, Alyssa, but since you answered, I'll let you go.
Sorry.
That's okay.
But inner lining of the organs, sorry.
Lining the hollow organs, primarily. Where do we find skeletal muscle?
The bones?
Nope.
No?
Trick question.
Everywhere?
Pretty much everywhere, yeah. Generally, if you wanted to put that, Marley, what you would say is attached to the bones. Attached to the bones. It may seem like I'm nitpicking, but I'm wanting you to get into the habit of knowing that we're looking at different levels of organization here, right? We have to look not just at what we're interested in, but we have to look at a level below that at the cells that make it up. We have to look at a level above that and see how it's connected and organized in relation to other things. So is everybody comfortable with that? Not sleep on me, are you, Haley?
No.
Okay. Where do we find epithelial tissue? If you had to pick one location, what would you pick, Will, for epithelial tissue? Yeah, the skin. Outside. That'd be fine. Would you get credit for saying the lining of the gut? Yeah, because that is where you find it. Pretty much any surface exposed to the exterior environment. Everybody cool with that? And don't worry, we'll talk more about the epithelial than you ever wanted to know. I think we've already started that, in fact, hadn't we? Gone over the difference between the cuboidal and columnar, yeah. Connective tissue. Where do you find connective tissue? This is a trick question.
Everywhere.
Everywhere. Good job, Raven. Connective tissue is probably the most diverse kind. If you start splitting it up and dividing it into specifics, the obvious things would be bone, which is found in the skeleton. blood. Now, if you wanted to be fancy and say it's found in the circulatory system, that's a better answer than just saying everywhere. But it is everywhere because the circulatory system goes throughout the entire body, doesn't it? What's going to probably present some difficulty for you are when we start talking about the different types of specialized or less specialized connective tissue, the general connective tissue. The thing to remember about connective tissue, what distinguishes it is its ECM. It's ECM. Now, if you remember, ECM stands for extracellular matrix. Each type of connective tissue will have a very, very distinct ECM. The ECM is primarily made up of two things. Number one are protein fibers, three things. Number one, protein fibers. Number two is a ground substance, a ground substance. The ground substance is what will vary the most. It's typically going to be made up of non-fibrous proteins. And other molecules. Those other molecules can be things like calcium carbonate in the bone. They can be polysaccharides. You get an idea. And then the very last component of the ECM is going to be fluid. Now the fluid can be either a major component or a minor component. It can be either major or minor. Can anybody give me an example of where it would be a major component? What type of tissue?
Stomach,
Nope, it's not a bad guess.
blood,
Blood, yeah, blood. In fact, the ECM of the blood is, for all intents and purposes, a liquid. And when we start talking about plasma, which is the liquid component of the blood, there's a lot more in it than just water, though. Can anybody give me an example of where it's something like calcium carbonate? Bone. Proteins, the ECM there would be something like muscles. So you get an idea, it's not just connective tissue, is it? Every type of tissue has an ECM, but in connective tissue, it is the most diverse and it is generally directly related to function. It is generally directly related to function. So we've covered the major cell types. In epithelial tissue, right? Columnar, simple, complex, all that. Now we're going to talk about the major cell types in connective tissue. The first up are fibroblasts. Fibroblasts. These are primarily responsible for repair. They are what create and distribute the ECM. They're what lay down the ECM. And if you're wanting to follow along in your book, this is on page 70. Page 70. Everybody see the part where I'm at? Okay. Next up, macrophages. Macrophages. Macrophages are pretty interesting because they're essentially white blood cells that migrate out of the circulatory system into the surrounding connective tissue. You may, yes, ma'am.
Can you repeat that last thing that you said?
I can, but I won't. They are white blood cells that leave the circulatory system and go into the surrounding connective tissue. And that surrounding connective tissue, again, it's found throughout the body, right? So what these do is they more or less act as wandering guardians, looking for viruses, bacteria, damaged or dead cells. You get an idea here. Not just an immune response, but kind of like a janitor as well, cleaning up the damage or degraded tissue. Am I going too fast? Third type are called mast cells. Mast cells. Mast cells play a role in the immune response. They're found near the circulatory system. They're part of the connective tissue, but they're always found near the circulatory system. The reason for that is because they secrete chemicals which affect the circulatory system. The first one is a substance called heparin. Heparin. Heparin is a protein that is essentially an anticoagulant. It prevents blood clots from forming. Now, in some cases, you want blood clots to form, don't you? If you cut yourself, you don't want all your blood leaking out. So that's a good thing. But you also don't want blood clots to form inside the big vessels of the circulatory system. Because if they do, they can break off and travel until they get lodged in a smaller vessel and act like a block. Does everybody understand where I'm going with this? The heart is a muscle, isn't it? Does it need its own oxygen and nutrient supply? Yes, it does. What may surprise you is the cardiac muscle is supplied by its own blood vessels. It does not take anything from the blood that actually passes through the chambers of the heart. It has to have its own supply leading specifically to the muscle. If you get a clot that breaks off and blocks one of the arteries supplying the cardiac muscle, is it going to continue to live? It's dead. This results in what we call a myocardial infarction. A myocardial infarction. Does anybody know what the common term for a myocardial infarction is? A heart attack. The thing to understand about this, though, everything downstream from that clot dies. Do you get that heart muscle back? It's gone forever. So if your heart loses 20% of its muscle to a heart attack, for the rest of your existence, you now have a heart that only pumps at 80% capacity max. See why it's a serious issue. So you don't want clots forming in those kinds of locations, do you? You can also get them forming and carried to the brain, and everything downstream in the brain dies. You don't get that back. We call that an ischemic event, The common term for it is a stroke. So you understand mast cells are pretty important, aren't they? Most of you, I hope, at your age, are probably not having to worry about blood clots. For most of you, the most important substance these things secrete is probably called histamine. Histamine is a compound that helps initiate what we call an inflammatory response. An inflammatory response. And I'm just going to pause here and give you the generalized inflammatory response so you know what it is, okay? Has anybody here ever sprained an ankle? A lot of us. First thing it does, it hurts, doesn't it? Well, that's your nervous system letting you know there's damage. That's not part of the immune response or the inflammatory response. What is one of the most common symptoms other than pain? Somebody raise their hand and tell me. Swelling. The technical term for that is edema, E-D-E-M-A, edema. And that's caused by histamines. What happens, the cells making up the blood vessels actually open up little gaps between them. And the fluid from the bloodstream starts leaking into that extracellular space. The reason for that, it helps nutrients get to the other tissues. It helps white blood cells get in there in case there's any kind of infection. It helps fibroblasts get in there to start laying down repair. You see how this works? So swelling can actually be a good thing. What's another symptom besides pain and swelling? Bruising. What that is indicating is the blood vessels have been broken and the blood is actually leaking out into that extracellular space as well. But more immediately, it generally gets hot, doesn't it? I always tell you to put ice on it. The reason for that is because Histamines are a vasodilator, They dilate the veins, which means they open them up. Are you getting more blood flow through there? It also gets red, doesn't it? That's where the term inflammation comes from, inflamed. It looks like fire. Well, that's also because of the increased blood flow. Other things it does that you may not be aware of, it stimulates the production of mucus. We talked about the goblet cells already, didn't we? Yes, no, maybe? Remember I told you how they produce mucus? You produce up to a quart a day. Does anybody in here have seasonal allergies? Just about every hand goes up. If you look, you're probably taking something similar to what's in this little bottle right here that says antihistamines. Anti means against, right? An antihistamine is working against it. Well, that's exactly what it's doing. It blocks the histamines, so it dries up that mucus so you don't have the sniffles. It also means that if anybody in here ever gotten in poison ivy and treat it with an antihistamine cream? When that foreign substance gets into the skin has an immune reaction, doesn't it? It's local inflammation. We call that contact dermatitis. An antihistamine lotion, like Benadryl lotion or Caladryl, can actually help block that response as well. Now, the mast cells can go crazy. I know of one scenario where there's something called mast cell activation syndrome, MCAS. And I know of one case where a young woman your age basically developed this, and it was an extreme allergy against hair. She actually had to have every hair in her body permanently removed because it was causing life-threatening responses. Kind of crazy, isn't it? So you get the idea how important mast cells are. And let's see. Those are the three types that you need to know, those three. All right, take a 30-second break, stand up, stretch, pop your joints. Take you a sip of something caffeinated. Did anybody watch the Super Bowl last night? Who won?
Eagles.
Good. It's not that I'm an Eagles fan. I don't care for any pro team. I'm just glad the Chiefs lost. If I see another Taylor Swift picture on football. And I know that's not her fault.
She got booed last night. One of my friends sent a video. The Eagles fans booed her whenever she went on the screen.
Well, that's not her fault. I always tell people, though, if I wanted to watch somebody chase a ball, I'd go outside and play with my dog. Wish my dog got paid for this, guys. Okay, everybody with me now? What we're going to talk about now are the components of the ECM for the connective tissue. The components. The main one that you're going to hear is collagen. Collagen is a very thick, fibrous protein. It's the major structural protein of the human body. It's somewhat elastic. It has very high tensile strength. Tensile strength, T-E-N-S-I-L-E, just means it can withstand great pulling. You're mostly going to find collagen fibers in the ligaments, which go bone to bone, and the tendons which are muscle to bone. And that's not surprising because those typically have a lot of force exerted on them, don't they? So you're going to need something that's strong. Am I going too fast? We're going to compare that to something called elastin fibers, E-L-A-S-T-I-N. Elastin fibers are exactly what it sounds like, elastic. They're flexible. They're weaker than collagen fibers, but you can easily stretch them and they'll snap back. Now they have a limit. I think we've all had our favorite pair of Fruit of the Looms where they get the waistband just blown out. But it's the same principle, isn't it? That elastic allows flexibility. That's the key. It's weaker than collagen, but it's far more flexible than collagen. So any part of the body that's subject to a lot of stretching, you'll find it. Vocal cords, airways, you might sometimes see these two referred to as yellow fibers and white fibers, the white fibers being collagen, the yellow fibers being elastin. That's not a good descriptive term, but it's one of the older ones you may encounter because of the color that the tissues typically look like under the scope. And then the final type are called reticular fibers. Reticular fibers. As we saw from the endoplasmic reticulum, that's a word that means network. Network. These are thin, delicate fibers that form a net or a web. A net or a web. Good place to find them, the spleen. Spleen. And finally, the ground substance, just to reiterate, it's what fills the spaces between the fibers. The body is constantly producing these types of proteins. I love all these shampoo ads where they say their shampoo contains collagen. Well, your hair is not going to absorb the protein from the shampoo and digest it. That's just marketing. The collagen in your hair is manufactured by your body, right? You get an idea here. The main thing is it's used in growth and repair. Growth and repair. Collagen can be about 70 to 90% by weight of muscle, tendons, that sort of thing.
Repeat that again, please.
It can be about 70 to 90% of the weight of muscle and skin, tendons. What might surprise you is that collagen is also a major component of bone. Has anybody here ever taken, say, a drumstick and made a rubber bone out of it? Did y'all ever do anything growing up besides look at your phones? Y'all want to hear how to do this? It's pretty fun. Next time you go to KFC, get yourself a drumstick. Once you're through eating it, take what's left over and throw it into a jar of vinegar or pickle juice. What's going to happen, the acetic acid that's in the vinegar is going to dissolve the calcium carbonate in the ECM of the bone, and it's going to pull it into solution, okay? If you leave it in there a couple of weeks, pour off the junk and take out the bone, it might look a little bit darker, more brownish, but it's still going to look pretty much like the chicken bone. But where if you took the chicken bone and did that, you would snap it, right? If you take the one out of the vinegar and you do that, it's going to flex, just like it's made out of rubber. The reason being, you have removed all of the hard part of the ECM, and what you see left are the collagen fibers connecting it all together. And of that protein, 60% of it is collagen. But you didn't know that, did you? It's a major, major component of every structural connective tissue. That's the main thing I want you to understand. Can you get too much of it? Absolutely. My mother has a unique condition that I'm going to have to watch out for, called contracture, which is where the ligament, or the tendon right here, is building up excess collagen to the point where it's causing her fingers on her right hand to curve in like that. And it causes her a fair amount of pain. She's still able to force it open, but she might have to have surgery. Talked with the doctor last week, and she's actually going to go see a hand specialist about it. Now, at her age, she's lived to be 84. I think that's pretty good if that's about all she has to deal with. But you get an idea here. If you tear a ligament, will it regrow? No, it will not. But y'all didn't realize that. Has anybody here ever torn a ligament? What happens, you may hear a very common injury is the anterior cruciate ligament in the knee that gets torn in athletes. When that happens, what they have to do is take a donor ligament, a ligament from a dead body, cut open the person, cut their own ligament out, and put the donor ligament in. Did y'all realize that? Don't frown at me. I'm not the one who came up with this. It may seem pretty brutal, but the point is, these are pretty tough tissues. It takes a lot to tear them. There's not a lot of living things. I actually had surgery in my left shoulder because the ligament in there that was holding the arm into the socket lost its elasticity. I have a bone spur from where I separated my shoulder years ago playing football, and the ligament was rubbing over that bone spur, and it got frayed to the point where it was no longer holding it in. So what the doctor did was he took, like, let's say that this is the frayed spot, he made a little knot like that and stitched it together. Y'all see how that's shorter now? And it's tighter. And I've got this knot. Feel it right there. It's pretty weird. It moves around. But I've not had any trouble with it since. Point is, connective tissue injuries are hard to heal. They take time. What we call a sprain is typically a partial tear of a ligament. They grade sprains based on how much of it is torn loose. It can re-anchor itself as long as you have it completely torn it loose. So everybody okay with that? So let's talk about different types of connective tissues. Different types of connective tissues. The first is going to be called connective tissue proper. Connective tissue proper. And we're going to subdivide this into loose connective tissue and dense connective tissue. Loose connective tissue and dense connective tissue. I'm going to give you the different types of each, and then we'll add the descriptions. Does that sound good? So the three types of loose connective tissue. Number one is areolar. Areolar. A-R-E-O-L-A-R. A-R-E-O-L-A-R. Areolar. Number two is adipose. Adipose. A-D-I-P-O-S-E. A-D-I-P-O-S-E. And when you try to find adipose connective tissue in lab, it's very difficult. So you may need to get help with that. Feel free if you do. The third type is called reticular. Reticular. R-E-T-I-C-U-L-A-R. Would anybody like me to repeat any or all of those? You got them in one. Okay, good job. Now the three types of dense connective tissue. Number one is regular. Number two is irregular. And number three is elastic. Elastic. So has everybody got all six of those? Okay, now let's start talking specifics. The first up is going to be areolar. Areolar connective tissue are delicate, thin membranes that bind skin to the underlying organs. The space between muscles. At the risk of sounding gross, has anybody in here ever skinned an animal? Wow. Well, if you do, when you're peeling the skin back, there's this very thin layer of almost fatty tissue, right? And you have to just kind of ease that away. That's areolar tissue. If you are ever doing a muscle dissection and you're trying to pull the muscles themselves apart, there's a thin membrane in there. That's areolar connective tissue. Everybody comfortable with that? Got an idea of where it is and what it is? The main thing there, it just more or less is a binder. It's a binder. It holds things together. It's mostly made up of fibroblasts. Fibroblasts. Next up, adipose tissue. This is sometimes called fatty tissue or fat tissue. The cells are called adipocytes. Adipocytes. A-D-I-P-O-C-Y-T-E. And these are basically cells that are full of lipids, aka fat. The fat droplets are so big that they essentially push all of the cytoplasm and the organelle off to a side. And what it looks like is just a big open empty space. If you take a look at figure 5.20, these are really, really hard to see under the microscope because when you're putting it under there, the only thing you're really seeing is just the network of the plasma membrane and all that cytoplasm squished up to the side. And these serve two functions. Number one, obviously, they're energy storage. Let's list three functions, actually. They're energy storage. This is why if you consume more calories than you use when you tend to put on weight in the abdomen, it's all getting stored in that adipose tissue. It also is a very effective insulator. If you look at groups of people that are indigenous to the Arctic regions, you'll notice that they tend to be shorter and stockier of a heavier build. And a large part of that is the way the adipose tissue is deposited and laid down. It's not just an energy storage, but it actually acts as a good insulator, helping retain body heat. So everybody got that? And the third one, this is to a lesser extent, but it's one I still want to mention to you. It acts as a cushion. It acts as a cushion. And not necessarily in ways you may think. Behind the eyeballs, you've got some adipose tissue. So if you get your head knocked back, your eyes actually have a bit of a cushion. Around the joints in the body, you'll have a bit of a cushion there. The kidneys, and this is sometimes further broken down into white adipose tissue and brown adipose tissue. The white tissue stores the fat, the brown tissue breaks it down. So if you need a lot of heat, the brown fat cells, they have lots and lots of mitochondria to break those fat droplets down. And I apologize if this feels like a slog. I know it is. Connective tissue is not my favorite chapter to teach. Y'all with me? Reticular connective tissue. Think of this as a three-dimensional net, almost like a spider web. It's just a framework. The liver and the spleen both have reticular tissue. And that's all that we really need to say about it. Haley looks disappointed. Do you want more, Haley?
No, I think it's simple.
Okay. Take you a 15-minute break. Y'all are looking a little antsy. Stand up and stretch. Sometimes you just need to look away, don't you? What are y'all up to? About 2.5 pages, 3? Yeah, like I said, I apologize. This is pretty much a slog. You think it's bad to take notes on it. Imagine having to lecture on it. How to make that exciting. This is a network of connective tissue. This is a network of connective tissue. And guess what this is going to be? You guessed it, a network of connective tissue. Thud,
So
thud.
what would be the best way to like memorize all of it, you think?
The best way to memorize it would be to break it down like I told you. We start with proper, then we divide it into dense and loose. The 3 loose types are what we just went over: areolar, adipose, and reticular.
What I
Areolar,
want to do is like make flashcards.
that's what I would do. Try the memory palace. So everybody got it? You with me? All right, now let's move into the regular connective tissue. Dense regular connective tissue is packed with thick collagen fibers. It also has elastic fibers and a few fibroblasts. This is going to be your tendons and ligaments. The main thing to recognize about here is this is avascular tissue, AVASCULAR, which means it does not have its own blood supply.
Can you spell that again?
AVASCULAR. If we say it's not vascularized, or I use the term avascular, it just means it lacks blood vessels. This is one of the reasons that tendon and muscle and ligament tears are so difficult to heal from. There's just not a lot of stuff there. If you had to get a single word here, strength. Strength. And bad news for all of you vain young people. As you age, well, guess what happens? Those collagen networks lose their flexibility, and then you get these things called wrinkles. It's just a natural part of aging. It happens. Some cosmetic procedures allow you to inject collagen into these tissues. Will do away with the wrinkles for a short period of time, but eventually those will break down and you'll have to repeat the process. My favorite one is Botox. Do y'all know what Botox is, what it stands for? Botulinum toxin. It is the same toxin that's found in botulism. And what it amounts to is when you inject Botox into your skin, you are killing off the nerve endings. So the muscles relax. They will not tense up, whether you want them to or not. Now, eventually, after a few months, the nerve endings will reform a new connection away around that, and you get some of it back. But each time you do it, you look less and less expressive until you have one face. And I mean one face only, because you have no expression left because all your facial muscles are paralyzed because you've injected them with this toxin. Don't look at me. I'm not the one who cooked it up. I always tell people, you got to age at some point. You can't turn back the clock, can you? It also is what makes some people's skin look leathery, especially if you've had a lot of exposure to, say, shortwave ultraviolet radiation. In other words, if you visit a tanning bed a lot, by the time you get to be my age, your skin will look like boot leather. You're just damaging it. Next up, elastic connective. These are primarily elastic fibers. There's some collagen and fibroblasts. And you'll find these primarily the airways. Ligaments between the vertebrae, the ligaments between the vertebrae. And let's call it right there. That way, when we start up next time, we'll start in with the special.